In the remaining few videos, we're going to concern ourselves with optical illusions, which are a lot of fun, to be honest with you. But we're interested in them because optical illusions can tell us a lot about seeing. There is something odd when we speak of an illusion, because seeing is usually held as some kind of gold standard of truth. I see it with my own eyes, we say. And of course, we're all aware that we can be mistaken, and there are occasions in which what we seem to see is not quite what we see. There are many ways to design illusions. They're not all visual illusions, there are also auditory illusions. And one thing I would ask you is, can you imagine an olfactory illusion? Is it possible to smell something that's not there? Gustatory illusion? They're by no means common. There is a website, illusionoftheyear.com, which is well worth going to every year, because every year they have a competition for new illusions. So many of them are there. And every year we find new variants on old themes and sometimes brand new illusions. So in each of the ones we're going to look at here, some of them will be familiar, some of them will not. There is a sense in which something has been created that tricks the visual system. Now, vision evolved to serve the purposes of organisms. That means vision's role is to help you survive. Vision's role is not to deliver truth, it's to help you survive. So it's not too surprising that we can find particularly images that trick us, because vision didn't evolve for analyzing images, and it didn't evolve for many of the paradoxical situations that we put ourselves into as illusions arise. So what these illusions illustrate collectively is that we understand vision better when we see it as a form of intelligent sense-making, inquiry into the world, engagement with the world in order to make sense of it, and not simply as picking up pre-existing information. So let's have a look at some. There's an old chestnut. You may be familiar with this. You see a green cylinder on a black and white checkerboard. The squares labeled A and B are actually the exact same shade, but that's not very apparent, is it? If I cover them up, or rather cover up everything else, there's the two, and you can see the tricks of the designer here. The font is white on one and dark on the other, which accentuates the contrast. But if we go back here, you still can't see them as the same shade, can you? Because when you encounter this scene, you first of all render it meaningful, and that means you see it as an arrangement of three-dimensional objects in space, illuminated from the right. The shadow that appears to be falling over the square B helps to make sense of this scene, and it's only by removing those cues that speak of the presence of objects in a three-dimensional space that we can see that the pixel values of the squares are in fact identical. Now, I've been teaching this course for a long time, and in 2015 we had just done optical illusions when this happened. The dress that broke the internet. This was a crappy photograph taken by someone at a wedding of a dress, and it turns out that people disagreed as to how to describe the colors of this dress. Should one understand them as black and blue or as white and gold? Now those sound like ridiculously contrasting elements, and I confess I can only see this in one way. I can only see this as a white and gold dress, which turns out to be the wrong answer. Notice how bad this photograph is. Notice how little context you have, how little information you have about the space in which this person is standing, about the direction of illumination, about the kind of shadows that are being cast, about the way that other surfaces appear. This is a really terrible photograph, and its ambiguity lies in that lack of information that normally is a secure guide. Here's a very helpful illustration showing how the same pixel values can appear in those two combinations. On the left-hand side, if you illuminate a black and blue dress with yellow light, that's what it looks like. On the other hand, if you illuminate a white and gold dress with blue light, you end up with something much the same. So when this image started getting passed around, everyone was very vocal in their opinions. Everyone knew that they saw it the correct way. And because of the reach of social media, it was possible to make this an informal experiment with a very, very large subject population. And in fact, at some stage here we had about 50-50 split between the two interpretations. But look at the numbers, 137,000 voting for black and blue, 131,000 voting for white and gold. These are not numbers you normally get in a psychological experiment, and they attest to the extreme ambiguity of the image. But it is remarkable that people only tend to see this in one way. I don't know if you can see it in both ways, and I don't know what you see. Again, these are fun in class where we can query the whole class. Perhaps you want to check with your flatmate. There'll be a paper that goes into this in more detail on Brightspace. Okay, here's another fun illusion. And again, this requires you to sit about 50 centimeters away from your computer monitor and to monitor that fixation cross. Very many optical illusions have this requirement that you not move your eyes. And we've seen already that that's a pathological sort of way of seeing. And so it's not surprising that odd things happen. But what happens here is very odd indeed. What you see are a bunch of purple dots. And there's one of them missing. When I make this image move, the missing dot is going to travel around. That is, the dot will wink in where it's currently missing and the next dot will go out. And that's all that's happening, I guarantee you. What you're going to see sounds fantastic. You're going to see the sudden appearance of a green dot that's not there. And then it's going to eat up all the purple dots until they're all gone. As soon as you move your eyes, the whole thing goes away. So let's give it a shot, shall we? I find this very effective. Again, I can't be sure it worked for you. From Illusion of the Year, we get very many complex images like this that combine high contrast elements, sometimes with moving elements. The two colored dots, they keep changing color, here are moving in straight lines, but depending on where your gaze is fixed, they may appear to be not moving in straight lines. Sometimes static configurations like this can be used. So there are, as it were, 4 circles here, each of them composed of squares. But these squares are tilted so that there are low-level contrast cues that speak of a spiral rather than a circle. One of the old chestnuts of the visual illusion world is the Ebbinghaus illusion, usually shown as a static presentation of 2 figures, one of a central dot surrounded by smaller dots, as here, and one of that same dot surrounded by larger dots. And the illusion is that the central dot appears to be of different sizes in the two, even though it's the same. But this is much more convincing when we make it move like this. So the central dot is actually unchanged in size, while the surrounding dots are changing. Here's a slide that illustrates some very clever use of contrasting elements in order to suggest movement. Nothing is moving in the image here. Absolutely nothing is moving in the image here. Notice that this peculiar illusion doesn't use the fixation cross. Your eyes are free to roam all over this. And in fact, the illusion arises as your eyes roam all over this. If you fixate, let's say, the center of the Buddha in the middle, for me anyway, the movement stops and the movement comes back again as my eyes roam all over it. So you can see how optical illusion designers are playing, as it were, with this peculiar property of the eyes, that they move over things normally, and if they're held still, then they interpret the peripheral visual field rather differently. We have more illusions in the next video.